All right, symmetric matrix. What is symmetric matrix? When a matrix is equal to its transpose, the matrix is said to be symmetric. You see, if you don't know what is a transpose matrix, you need to watch my video on that to know what is a transpose matrix. So when you have a matrix and that matrix you transpose it, the matrix is still the same, then we call it is a symmetric matrix. E.g., let A equals to this matrix, then the transpose of matrix A will be equals to this. Why? Because this is the first row. This first row, 2 and minus 3, will become the first column. 3 and minus 2, which is the first row, will become the first column. 3 and minus 2. Then the second row, minus 2 and 1, will become the second column, minus 2 and 1. You discover that this particular matrix is not different from this matrix. So a matrix A is the same thing with its transpose. So therefore, this kind of matrix, if you have them like this, you see matrix A is equals to this, its own transpose. So matrix A is symmetric. If you have them, it's a symmetric matrix. The next one is skew symmetric matrix. What is a skew symmetric matrix? A matrix A is said to be skew symmetric if its transpose is equal to its negative. Alright, if you have a matrix and you find the transpose of that matrix, the answer that matrix is going to have is a negative of that original matrix. If you have it like that, then we call it skew symmetric. Example, if you have, let A, matrix A be equals to this, then we have to find the transpose. If you want to find the skew symmetric of this, whether we want to find out if this transpose matrix is a skew symmetric matrix, we have to, the first step is to find the transpose of matrix A. And the transpose of matrix, A is, see, the first row become the first column. That's how to find the transpose. Second row becomes the second column. Third row becomes the third column. All right, by the time you find this, if you take this original matrix and you multiply each of the term or the element by minus, if the answer you are going to get if you multiply each of the element by minus, if the answer you are going to get is the same thing with this transpose, then this matrix A is called skew symmetric matrix. Now let's use minus to multiply by the original matrix A. Minus times the matrix A, it will affect here, which is still 0. Here is minus 2 before it becomes 2, because minus times minus is plus. Here is 3 before minus times 3 is minus 3. Here is 2, minus times 2 is minus 2. Minus times 0, everything is 0. Minus times minus 5 will give us plus 5. Minus times minus 3 will give us plus 3. Minus times 5 will give us minus 5. Minus times 0 will give us 0. So look at this matrix. 0, 2, minus 3. 0, 2, minus 3. Each of these elements here is the same thing with this element here. So therefore, the transpose of this matrix A is equals to minus of the matrix itself. So if this can be obtainable in any matrix, that matrix is called skew symmetric. Square matrix. What is a square matrix? Okay, it's a matrix with equal number of row and column. E.g., if you have a matrix that have equal number of row and column, it's a square matrix. This is row 1, row 2, this is column 1, and this is column 2. So 2 rows, 2 columns. This is a square matrix of order 2 by 2. This is row 1, row 2, row 3. This is column 1, column 2, column 3. So this is a square matrix of order 3 by 3. So this is what we call a square matrix, when the number of rows is equal to the number of columns. Okay, so the next one is triangular matrix. What is a triangular matrix? Is a matrix whose entry, okay, either above or below principal diagonal are 0. Okay, e.g., 1, 3, and then 0, 3, 4, 4, 0, minus 1, and 3, 2, 3. This is another matrix. This is another matrix again. Why do we call them triangular matrix? Remember, we say it's a matrix whose entry either above or below the principal diagonal are 0. Principal diagonal is, now, The principal diagonal of this matrix is 1 and 3. 1 and 3. So above it is 3, but below it is 0. Because below the principal diagonal, which is 1 and 3, is 0, therefore we can call this a triangular matrix. Note of here, the principal diagonal here is 4 and 3. 4 and 3. Above it is 0, and below it is minus 1. So since above it is 0, okay, so it is also a triangular matrix. Look at here. The principal diagonal of this matrix is what? Is 2, is 1, and minus 5. 2, 1, minus 5. So below 2, 1, minus 5 is discovered that the remaining part here is 0, 0, 0. So therefore, below the principal diagonal is 0. So you can call this triangular matrix. Also here, the principal diagonal here is 4, 3, and minus 3. 4, 3, minus 3. Above it, you have 0, 0, 0. That fill up there. So therefore, you can call this triangular matrix. Okay. So we have scalar matrix. A matrix such that each of the entry or entries along the principal diagonal is equal and non-zero, and whose elements of the principal diagonal all being 0, e.g. now if you have 2, 0, 0, 2, and this the same matrix, these are example of scalar matrix. Why is this called scalar matrix? If scalar matrix in the layman term is if the principal diagonal is a number and every other entries, whether above or below, must be 0. If they are 0, then we call it scalar matrix. So if you have every element in the principal diagonal to be ordinary number and not 0, but every other element becomes 0 apart from the principal diagonal, we call that kind of matrix scalar matrix. Okay, now what is unit matrix? Unit matrix is a scalar matrix, okay, such that each of the entries along the principal diagonal is equal to unity. Unity means 1. Okay, so unit matrix has to be a scalar. Why is it scalar matrix? Because every other entry will be 0 apart from the principal diagonal. But this time around, this principal diagonal, if the principal diagonal become 1, 1, and 1, then we call it unit. Unit means 1. But if this principal diagonal, if any one of them is above 1, all right, we call it scalar matrix. Okay, which is the one we just, discussed before now. Then this is a 3 by 3 matrix. This one, the principal diagonal is 1, 1. So other entry is 0. So this is a unit matrix. So a unit matrix is usually denoted by the letter I because it's unit. All right. Then we have a null matrix. Null matrix. A matrix with all the entries 0 is denoted by the symbol empty bracket. E.g., you see, all of the elements here is 0. So it's a null matrix. Look at all the elements is 0. It's called a null matrix. Thank you. Don't forget to share and like and subscribe on YouTube. This is brought to you by Brain Hub Academy by Kenneth. Thank you.